Multi-agent systems drown the supervisor in copied histories. LangGraph handoff tools and last message routing keep each specialist focused without letting context grow unchecked. You'll learn how the pieces fit into a workflow that routes each request and hands only needed context to specialists. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. LangGraph supervisor handoffs solve a practical pain point. In many pipelines, a single coordinator asks many specialists for help. The naive way is to copy the whole conversation to every specialist. That quickly explodes token costs and widens data exposure. Success here looks like a supervisor that decides who should act, routes the task, and gives each specialist only the information they actually need to complete it. Think of a customer support scenario. A supervisor reads a short message and routes it to billing or refunds. If every agent got the full history, you would pay more and risk leaking unrelated details. LangGraph gives primitives that let you build the supervisor flow, explicit transfer tools, and a worker view that trims what each specialist sees. That keeps costs predictable and audits possible. I want to build a tiny, debuggable demo that shows the pieces. Explicit handoff tools, a supervisor decision step, wiring that delegates control, a worker view that trims history, and a small audited run that records which handoff happened. This demo maps directly to the ticket routing example and should feel safe to inspect and extend. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now let us start by creating the handoff tools the supervisor will use to transfer control. This snippet creates two LangGraph supervisor handoff tools for explicit delegation. Copying every supervisor turn into every specialist is where token growth and data exposure usually start. So, create handoff tool is configured with add handoff messages equals false. The code keeps the real tool objects in handoff tools and builds tools by route, so later routing code can connect an agent name to the actual transfer tool name. This is still lightweight, but it uses the same LangGraph supervisor primitive you would use around real specialist agents. The output shows the available transfer tools, which makes the delegation surface visible before any graph runs. With tools in hand, we need a supervisor that can decide from just the latest user text rather than the full log. This example routes with LangGraph command using only the newest message. A supervisor does not need the whole conversation to decide whether this tiny request belongs to billing agent or refund agent. The state shape keeps messages, route, handoff, and answer as the shared contract, while supervisor reads state messages -1 and returns command with both an update and a Godot target. That combination is important because the route is recorded for debugging, while control moves to the selected node. The output shows the chosen route, proving the decision can be made without expanding specialist context. That routing function works as plain logic, but we need it to run inside LangGraph, so control actually transfers to a named worker. This code turns the routing function into an executable LangGraph StateGraph. The supervisor node starts the run. Then command sends control to the node named billing agent or refund agent. The specialist functions are intentionally small, so the graph wiring stays visible. Each worker returns only an answer field, and the graph stops at end after that worker finishes. In production, bill and refund would wrap real agents or tools, but the control flow shape would stay the same. The output shows that the refund path ran, which confirms the supervisor delegated instead of asking every specialist to inspect the request. The specialists will still see the full state unless we intentionally hide parts of it. Next, we build a worker view that trims history. This snippet trims the worker-facing state before a specialist sees it. The shared graph state can still preserve full history for audit or recovery, but worker view returns a copy where messages contain only the last item. That is the core privacy and cost move. The supervisor keeps enough context to run the workflow, while the specialist receives only the task size slice it needs. If you increase the retained slice, specialists get more context, but spend more tokens and see more data. If you decrease it, cost drops, but ambiguous tasks may need a clarification path. The output shows how many messages were removed from the worker view. Finally, we connect the audit, the recorded route, and the bounded view into a single run you can inspect. This code combines the LangGraph pieces into a small baseline you can debug. Audited calls supervisor, looks up the matching handoff tool name in tools by route, and records that name and state before returning command. Refund bounded then uses worker view, so the specialist path proves it received the bounded message list rather than the full history. This gives incident debugging something concrete to inspect. The selected route, the transfer tool, and the context size seen by the worker. The output shows the exact handoff used, and the worker context count, which is the minimum useful signal for safe routing. Mapped to a real project, this pattern replaces ad hoc message copying in a ticket pipeline. Keep the supervisor logic compact. Store the full history for audits, and give each model only the bounded view it needs to answer. That makes costs stable and makes it possible to prove what any worker actually saw. To sum up, run a supervisor that makes the routing decision. Use dedicated handoff tools to move control, and give each worker a bounded view so you avoid dumping the entire conversation everywhere. Use this when you want controlled delegation, predictable token cost, and an auditable record of who saw what. One caveat: give the worker enough context, or you'll trade lower cost for more clarification back and forth. A practical next step is to tune the worker view retained slice and evaluate routing accuracy on your labeled ticket set to find the best balance between cost and clarity. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.